All right, we're continuing chapter 11. This is the third section, and I hope the first two went really well. Now let's take a look at what we got going on here. Well, what we have going on here is quadratics and factoring. So that's why we were doing all that factoring. Well, it's one of the reasons we were doing all that factoring, but let's take a look at what we got going on here, shall we? Let's look. All right. Quadratics. I told you this is going to be all you wanted to know about quadratics your whole life and then some. Everything you were afraid to ask all your life. So our standard form of a quadratic, what is it? Ax squared plus bx plus c. All right? Now, when we have this thing set to 0, like we do up in here, when 0 is f of x, and we have it looking like this, what are we doing when we're solving for x or w or whatever letter we have? Well, again, we're looking for those intercepts. We're looking for, what was f of x? F of x is y. And here y is equal to 0. Where is y equal to 0 on this particular graph? Well, y is equal to 0 here and here. That's it. Those are the only 2 points where you're going to have a y coordinate of 0. So I want to know where these x values are. What could I possibly put in here for an x that would make the y equal to 0? So what I'm looking for are my solutions, which are my x-intercepts, which are my zeros. These are also called the zeros of the function. So these three things are identical. It's just a different way of looking at it. I could say, what are my x-intercepts? And I could get my w's this way. Or I can say, solve for w. What are my solutions to the equation? It's the same thing, okay? So I'm going to take a look at my quadratic up there. And what do I have to do in order to get this thing solved? Well, remember, the only way that I can solve a quadratic right now is a times b is equal to 0. Then either a is 0 or b is 0, right? I don't have multiplication here, so I have to turn addition and subtraction into multiplication, and I do that through factoring. So here I have a standard quadratic. It's one of those easy ones. My variable is a w. I'm going to have different signs because my back one is negative. And my factors of 6 are 6 times 1 and 3 times 2. They have to subtract to a 1, so that's this pair here. I have a positive 1, so I put the bigger number with the positive and the smaller number with the negative. See how important factoring is? Now I can say either w plus 3 has to be 0, or w minus 2 has to be 0. So I solve these two linear equations, so w has to either be negative 3 or w has to be 2. There's my solutions. Okay? Now, checking. Boy, there's multiple ways to check this. The first way is to throw it back in the equation and see if it makes a true statement. Okay, so I have w squared plus w minus 6 is equal to 0. I'm just going to throw my negative 3 in there to check it. Wherever I see a w, I'm going to put a negative 3 in there. Negative 3 squared is 9. 9 minus 3 is 6. 6 minus 6 is 0. It works. So will this too. Now the other thing that's my solutions. Now I can also check to make sure that these are my x-intercepts graphically. Okay, so I'm going to use my calculator for that. I'm going to put in my equation. I have to use my x's, not my w's, but it doesn't matter. Okay. If my solutions are the same as my x-intercepts, then it should be crossing at negative 3 and 2, which it looks like it does. And I can test that out exactly through my table. There's one of them, negative 3. The y has to be a 0. These are the zeros of the function. This is where the x-intercepts are. And the other one is at 2. Good job, 2 and 0. Okay, so these are my solutions. I've checked them algebraically. Well, I've only checked one, but I could check the other one too. And I've checked them graphically to make sure that they are the zeros or the x-intercepts of the function. So here I have a negative 3 comma 2. Okay? That's all I'm doing this entire section. Solved by factoring. Well, what kind of factoring problem do I have here? I have an AC method. Okay, so you're going to go through this, the same thing. You're going to go through this and you're going to solve this using the AC method. A times C, and then proceed from there. You're going to turn it into the 4 terms, then into the 2 terms, and then you're going to solve. There is nothing that's new in here. Okay? Now here we have an equation that's equal to x, not equal to 0. So the first thing that you're going to want to do is you're going to want to rearrange that, and you're going to want to subtract your x across. I am not going to do all of these because we've been doing this stuff forever here now, it seems like. So I'm going to subtract my x across because remember I'm using this principle that has to be equal to 0. So now I have 4x squared plus 20x plus 25 is equal to 0. X minus x is 0. From here you can see that this is another AC method. Okay, 4 times 25, we've got factors of 100, they have to add to 20, blah, blah, blah. All right? You're going to factor, you're going to set each piece equal to 0, you're going to solve each piece, and then you're going to check to make sure that, first of all, they do work in the original equation, and that they are the x-intercepts through your graphing. Okay? Same thing here. We're going to move our 80x over. So I'd have 16x squared minus 80x minus 224 equals 0. Factor, set each piece equal to 0, and solve. All right, let me just pull that, whoops. Let's pull that down just a little bit. All right. Now when would there be no real solution? That would be if there aren't any x-intercepts. Okay, so it would be hanging in the air. Your graph would look like, you know, like this. Let's just take a look at that one. We have 16x squared. So you might want to graph these first, just to see if you do have answers, real answers. We always have answers. Let's take a look at the graph. I think it's probably way off. But no, well, yeah, it's pretty off. I was going to say these are some pretty big numbers, but it does cross in 2 spots. So you are going to get answers. Okay? All right. All right, so now we're into a different type of factoring. This does not look like a regular factoring one, although we can transform it. So here I'm going to do this 2 different ways for you. Okay, I've got x squared equals 144. The first thing that it tells you to do is to use a square root property. Do I have to? Well, no, I could factor. This one I can factor. So here I can, if I wanted to, subtract 144 from both sides. So now I have x squared minus 144 is equal to 0. All right. And what have I done with this? Well, I've really turned it into a difference of squares, haven't I? This is factorable. So here, I know that a perfect square minus another perfect square is 1 plus 1 minus. Square root of the front one goes in the front, and the square root of the back one goes in the back. Now I can set each piece equal to 0. Whoops. It's either that is 0 or that is 0. So this is my 2 choices here, 12 and negative 12. All right. Now let's use the square root property to solve. A little faster, but your choice. How do I get rid of a square? I square root. How do I do that? I do it to both sides. Do the same thing to both sides. So the square root of a square is itself. And the square root of 144 is your positive and negative 12. Remember that when we're solving, we always have to have the positive and negative values of these things. Okay? So again, we've got 12 and negative 12. Either way, we have 12 and negative 12. Fantastic. Now, how do I check this? I can't check this in here because this is a y equals. All right? I can check this in there. So I have to check that. I have to get everything over to one side. So I can check the x squared minus 144. And it's not going to be on here because my graph only goes to 10 and negative 10. So again, I'm going to have to change my window setting here. I want my max and my minimum x values. Let's go from negative 15 to 15 so I can see it. Right? Now I can see it. And it's crossing through at 12 and negative 12. Okay, it was just a little wider than what I had. Remember, Zoom 6 gets you back to that standard viewing 10 by 10. All right? Now, these you can use. So far, I've been able to use my calculator on all these because I can always put, I can always put the function in, and I can look for the zeros this way. My answer was, I can just hunt around until I see there's 1 0, and I can go all the way down to 12, and there's my other 0. Okay? But what happens when I have radicals and I have messy answers? Then I can't use the calculator. Okay? As in this one. There's no way that I can find it through here. All right? So if I put in this function, 5x squared minus 16, this thing is not crossing at an integer. It's crossing between things, and there's no zeros in here that you can see. All right? See how there's no zeros in there? That's because they're between numbers. That's why we have to make sure we know how to do everything by hand, because the calculator can't always help you. All right? Once I find them by hand, the calculator can help me check them. We'll do that, but I can't find them initially through the calculator. So everything needs to, you have to really be careful about using the calculator too much. You can't rely on it for everything. So what do we do here? It says use the square root property to solve. This is basically a hint telling you this is the best way to go about it. It's the easiest and the fastest way to go about it. Now when we get our answer, we're going to have to rationalize our denominators and all that good stuff. So we have to make sure that we know how to put a final answer in according to the rules of radicals, which we do. We just tested on that. So. All right, so when we have an x squared, we want to isolate the x squared first. So the first thing that I'll do is I'll move my 16 over. So I have 5x squareds, these are gone, is equal to 16. And then I'll divide through by 5. So that's always your first step, is to isolate what it is that you're looking for. All right. So that's what you want to do first. Then we take the square root. Okay, I'm going to go up here so I don't have to get a new screen. So if I take the square root of x squared, then I have to take the square root of 16/5 over here. The square root of a square is itself, and I want the positive and negative values of this. All right, what's wrong with that? Well, I got a radical in the denominator. Okay, so we have to go back to all those rules. So the first thing that I can do here is I can split it using the quotient rule. And I can say that the square root of 16 is just a solid 4. So that's a good start. Okay? But remember, my radical rules tell me I can't have this, so I have to rationalize. So I'm going to multiply by the square root of 5, both top and bottom. I want pairs of 5 down here. So this is equal to plus or minus 4 radical 5 over square root of 5 times the square root of 5 is the square root of 25, which is 5. So this is your final answer here. So you're going to have to make sure, and you can't use this plus minus thing. So we're going to have to put in one that's positive and comma, one that's negative. I think you can put the negative out front like that, or you can throw it, doesn't matter. Yep. Or you can throw it on top with the 4, doesn't matter. All right. So that's why we need to learn how to do things by hand, and we have to have all our radical rules. So how do we check that in the calculator? Well, I still can check it. I think I have this in there already, don't I? Do I have that in there? Yep. Okay, so I already have this in there, and I've got my graph, and I want to find out where these two numbers are. Okay? Well, first of all, I'm going to have to get some decimal. The calculator is going to give me decimal equivalencies for those. Okay, it's not going to give me the radical equivalencies. So the first thing that I want to do is I want to get decimal equivalencies for these. So I'm going to say, okay, what is 4 times the square root of 5 divided by 5? So I'm looking for a plus or minus 1.7889, about. Okay, that's what this is as a decimal. So let's just check this one here. It's really close to 2, and this one's really close to a negative 2. All right, so what are my choices on my calculations? We've already looked at the maximum and the minimums. Those were my vertexes, right? I don't want a vertex. I want a 0. These are the zeros of my function. This is going to be my intercept. So I want a number 2. Okay? And it's going to ask me to get on the left bound. I don't even know where my blinker is right now, so I've got to find it first of all. There it is. All right, so the left side on this one is going to be underneath. Okay, so I want to hit enter. The right side is on top of it, so I hit enter. And it says, do you want me to guess? And I say, yep, I want you to guess. Look at how close that is. 1.7889 and a 0. So that one looks good. So now I'm going to do this one. Again, I'm going to do another 0. Okay, and I'm going to want to get on the left side of it, which is on top. So I have to get, just keep clicking that till you see it again. That's my left. And I want to be on the right side. Then I want to guess. Negative 1.7885. Perfect. So this is a way to check it, but I can't use this to get my answer. I can only check my answer this way because I don't know how to convert negative 1.788854 into a radical form. But I can change my radical form into a decimal and check it that way. Okay? So it is terribly important to know how to do these by hand. All right. I think I'm going to need, do I need a new screen? I do. I need a new screen, and look what I found. I don't know how I did this, but all of a sudden I've got this. Where I don't have to do the minimizing the screen. Isn't that weird? All of a sudden I've got it. So, and I want, do I have my pen size? Yep, I do. Okay. All right, so now I want my solutions. Let's see, what do we have here? Remember what I said? What did I say before? Isolate your square. Is it isolated? Yeah, it is. Before we had to do some monkeying around. Here I don't. So here I'm just going to start out by taking the square root of both sides. So I'm taking the square root of x plus 7 squared is equal to the square root of 25. Square root of a square is itself. And here I have the positive and negative 5. Remember, whenever I'm solving, I have to have both values. All right, now I'm solving for x. Subtract a 7 across. So I have x is equal to plus or minus 5 minus 7. Well, we need to split this up. We need to get two different equations. We need the x is equal to positive 5 minus 7, and x is equal to negative 5 minus 7. So x is equal to negative 2, and x is equal to negative 12. Okay? So we're going to check it algebraically. Let's put a negative 2 in there. Negative 2 plus 7 squared equals 25. Is that true? Well, negative 2 and 7 is 5. And 5 squared is definitely 25, so that one works. Check. Let's check the other one, negative 12. Negative 12 plus 7 squared should equal 25. Well, negative 12 and 7 is a negative 5. But negative 5 squared is 25. Check. Now the other way that we can check it is to throw it into our calculator. Since these are whole numbers, pretty easy to check. We're going to get our function in there. I have to say that it's minus 25. I have to set this equal to 0 in order to get it into my calculator. And I'll see the negative 2, but I won't see the 12 because that's off my screen. So I can change my window setting for my X max to be at 15, so I get on the other side of that. Oh, no. It's negative 12. What am I doing here? I didn't want that. I want this as negative 12. Well, Simone, you should have gone to negative 15. You could see a little bit better. Kind of cut it off there. Sorry about that. There it is. Negative 2, negative 12. And to verify that so that it's exact, we would go into the table. Negative 2 is 0. And negative 12 should also be exactly 0. Perfect. So when they're nice, easy answers like that, then we can check it pretty easily through the table. Otherwise, we're going to be using that calculation button. All right, that's exactly the same. I don't think this one is going to be, though, because this one's got a 2, which is not a perfect square. So we should probably try this one. All right. All right, so here we're looking for the solutions, which are the x-intercepts. We've got our square isolated on one side, so that's really good. So we're going to just start by taking the square root, both sides. The square root of a square is gone, so all I have left on this side is this, and I have plus or minus the square root of 2. The square root of 2 is not perfect, so I have to leave it underneath the radical. Okay? So now I'm solving for x. So next step would be to add a 7 across. So I have 5x is equal to plus or minus root 2 plus 7. And then I divide through by 5. Messy, 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 but it's right. So now I have x is equal to plus or minus the square root of 2 plus 7 over 5. Well, as two answers, that would be x is equal to square root of 2 plus 7 over 5. Okay, that's your positive value. Or x is equal to negative root 2 plus 7 over 5. So that's how you're going to have to put it into MyMathLab. Okay? So you've got this one and then this one. So let's try this. Let's see. We have a fraction. And I don't have any radical mistakes here. I mean, I don't have a perfect square underneath there, and it's not in the denominator. So I wonder if it's going to want it split. I don't know. I have no idea if it wants it split or not. So we're just going to try it without splitting it and see what happens. So we have the radical 2. Get out from underneath your radical sign, plus 7. Don't drag that radical all the way across. Comma. Then we have another fraction. And I have the negative radical 2, get out from underneath there, plus 7 over 5. Let's see if it likes that. Oh, it does. All right. Now again, to check this, you would have to put in this value. You'd have to move your 2 over, so it's quantity 5x minus 7 squared minus 2. You would want to get your zeros out, right? These are not exact, so you'd want to trace them out with your calculation button here, and you want to get decimal equivalencies for these. And then you can check to see if you've got them right, okay, in a test situation. Here you're just dividing through by 2 before you start. Divide both sides by 2, so really what you're working with here is x plus 7 squared equals 20. Proceed from there. Okay? And that's it. 10 quick, easy problems. Well, okay, let's not say easy. 10 fairly decent problems. They're not too bad, but it really shows you how your factoring and your radical knowledge from those previous chapters come in handy. You know, math is just such a unique discipline that it just builds on previous knowledge. Like, you can't ever forget the previous knowledge, which is sometimes the hardest part about mathematics, is that you have to know everything, really. I mean, you have to have everything that you've learned in the past under your belt before you can move forward. So that's probably one of the biggest things about math that makes it so difficult, is that you can't just go, oh, well, we finished chapter 10, so I don't have to ever do that again. It doesn't work that way. So it's kind of like a language. You know, every word that you've learned, or every piece of grammar that you learn, carries forward, and you have to keep using it. So anyway, that's 11.3 in a nutshell, and I'll see you for 11.4.